Hey everyone, and welcome to this explainer. Okay, today we are looking at a concept that honestly sounds like it's straight out of a sci-fi novel, but I promise you it is happening right now. We're essentially taking the whole idea of cloud computing and moving it, well, literally way above the clouds. That's right, we're talking about taking the massive computing power that runs artificial intelligence and launching the whole shebang into orbit. NVIDIA, the leading AI chipmaker, has basically set its sights on the stars. And the implications this has for our technology, our energy grid, and really our entire future, they're absolutely massive. So, let's dive in. Okay, let's dive into this with a pretty incredible quote. Space computing, the final frontier, has arrived. Now that isn't some line from a Star Trek movie script. That is a direct quote from Jensen Huang, the CEO of NVIDIA. He actually kicked off the company's annual developers conference in Silicon Valley with this massive announcement. And what he's establishing here is that this isn't some distant futuristic pipe dream. It's an immediate reality. They're actively working right now to take AI intelligence to places it has literally never gone before.
So, here's our flight path for the explainer today. First, we'll look at the final frontier of AI. Second, we're going to meet the Vera Rubin Space One module. Third, we'll ask, why build in space? Fourth, we'll look at the cosmic vision. And finally, surviving orbit. Let's get right to it.
All right, part one, the final frontier of AI, moving our data infrastructure entirely beyond Earth.
Now, what's absolutely crucial to understand right off the bat is that NVIDIA isn't just going rogue here. This is rapidly becoming a fierce AI space race. We're talking about more than a dozen startups, huge established aerospace leaders, and major tech firms who are all actively racing to develop, test, and plan these space-based data centers. It's basically a modern-day gold rush, but for orbital infrastructure.
Let's move to part two and see how this builds in the real world. Meet Vera Rubin Space One, the core building block for these orbital data centers. To really kind of wrap our heads around the scale of this tech, I want you to visualize a satellite that's roughly the size of a small refrigerator. But, instead of keeping your leftovers cold, a startup called StarCloud is packing it with NVIDIA's brand new Vera Rubin module. This specific piece of hardware is officially scheduled to make its cosmic debut in a satellite launch this November. So yeah, we are literally sending refrigerator-sized supercomputers into the sky. And the power packed inside that small satellite, it's staggering. 100. The StarCloud 1 is expected to bring 100 times more computing power than any previous space-based operation. I mean, until now, computing in space has mostly been limited to, basic telemetry, some navigation, and relatively simple data processing. This new hardware, it's an absolute quantum leap in off-world processing capability. No question about it. And this brilliantly illustrates what all that unprecedented power will actually be used for. The Vera Rubin module is highly optimized for AI. To really get why this matters, let's break down the basic AI equation. It's pretty straightforward. Compute power essentially equals the number of parameters multiplied by the data size, right? So running massive large language models, like the Google AI model StarCloud is planning to use, requires astronomically high compute power to solve that equation. Traditionally, trying to do that from space would mean experiencing massive debilitating latency because you have to constantly ping servers all the way back down on Earth. But with the Vera Rubin module, the satellite can crunch that massive AI equation entirely on its own. It handles real-time sensing, autonomous functioning, and immediate off-planet decision-making without ever having to wait for a signal from Earth. It's a total game changer.
Moving on to part three, why build in space? I mean, if we have plenty of land on Earth, why go through the hassle of orbit? Well, it all comes down to Earth's growing AI power crisis.
Now, what's really interesting about this is the stark contrast between terrestrial roadblocks and orbital freedom. Here on Earth, AI's appetite for real estate and electricity is just insatiable. Tech companies are constantly hitting a wall. Hurdles with acquiring land, navigating crazy strict local regulations, and facing huge community resistance to building these giant power-hungry facilities. But look at the cosmic abundance side. Up in space, you've got infinite real estate and literally zero local zoning laws to worry about. And even better, by placing these satellites in sun-synchronous orbits, the data centers get a constant, uninterrupted beam of sunlight hitting their solar panels. So it's essentially free, limitless power that completely bypasses our already strained electrical grids down here.
Which brings us to Section 4, the cosmic vision, a look at the timeline to off-world computing. Let's walk through the timeline because the pace of this is kind of mind-blowing. In late 2025, StarCloud actually successfully launched the very first NVIDIA GPU into space as a sort of proof of concept. Fast forward to November of 2026, and we've got the scheduled launch of that fully integrated StarCloud 1 satellite running the new Vera Rubin module. But look at that final goal for 2036. That is just 10 years away from the StarCloud 1 launch. The industry is seriously predicting a massive structural shift in how we handle global data by then. They are moving fast.
So, the crucial point is captured perfectly by Philip Johnston, the co-founder of StarCloud. He said, "In 10 years, nearly all new data centers will be being built in outer space." Think about that. This isn't just a niche, fun little science experiment. They are pushing for a total paradigm shift. The actual intention here is that the default location for all future internet and AI infrastructure is going to be completely off-planet.
Finally, Section 5, Surviving Orbit, because we definitely need a reality check on the actual hazards of space computing.
Look, while the perks of limitless solar power and no zoning laws are obviously incredible, engineers have some pretty terrifying realities to deal with if they want this to work long-term. Space is a fiercely hostile environment. These orbiting data centers are going to be bombarded by high levels of cosmic radiation, which, by the way, can scramble data and just completely fry sensitive circuits. They also have to survive wild, extreme temperature fluctuations. And honestly, perhaps the scariest part, the constant, unpredictable danger of catastrophic collisions with space junk that's zooming around up there at 17,000 miles per hour. Truly securing our data means figuring out how to harden this hardware against the absolute harshest environment known to humanity. Which brings us to our conclusion and leaves us with one really provocative final thought to ponder. As the very AI that is increasingly running our world, our global logistics, our financial systems, our complex large language models, as all of that physically moves out into the hostile environment of orbit, how is this off-world evolution going to reshape our everyday future right here on Earth? Are we solving our terrestrial energy crises, or are we just exporting our biggest vulnerabilities straight up to the stars? It's a fascinating, complex reality, and one that we are for sure going to be watching very, very closely. Thank you so much for joining me for this explainer, and I highly encourage you to keep exploring these incredible leaps happening right above our heads.